7 segment display. Most of us we think that 7 segment display is a complex one and it is a very difficult one. But I say that it is a complex one but not difficult. It is very easy. Okay, let us discuss about this. And you know that 7 segment display consists 7 segments which we name as A, B, C, D, E, F, G. Okay. In order to glow our desired bit, we have to give the input for the um, for a particular segments only, so that it can glow and it appears as our desired number. So here I need one number. So I want to give only to B and C segments so that it can glow and it appears as one by glowing, and the remaining all are off because I did not give any input for remaining segments. Okay, so this is the concept behind these 7 segments. Okay, so that they give 7 segment display. Okay, next, in order to implement we need a logic diagram, and in order to draw a logic diagram we need a simplified expression, right? So in order to get that, we construct a truth table by using 4 variables. We know that 4 variables contains 15 logical variables, right? So here we need only 9 because in second segment display we can implement only 9 digits. Okay, um, by using 8421 code I can construct up to 9, and the remaining 10, 11, 12, 13, 14, 15 are don't cares we can consider, and A, B, C, D, E, F, G are my 7 segments. And in order to implement 0, I just want to give the inputs to A, B, C, D, E, F, and we did not give G. We did not give any input to G because if I give G, it can appear like this. If I did not give input to if I did not give input to G, so it appears as 0, right? So same similar concept here I gave, and I for 1 I need only for the inputs to B and C, and I did not give A, D, E, F, G. So I wrote like this. So similarly you can fill this truth table. And next, B, C, D, E, F, G. So coming to k map simplification, I told that I took up to 9 remaining ones. We have to consider don't cares, right? And after in order to get a expression, which means a simplified boolean expression, we need to consider column wise. So here B, C, D, E, F, here sorry B 5 6 7 8 9 means here 5 6 7 8 9 are all are ones. And here you can see that from A only 0 and 2 3 are 1, and you can see that 1 and 4 are zeros. Okay, except 4 and 1 are zeros, remaining all should be considered as 1. So I took that 0 1 2 0 1 2 3 2 and 3. In kmap you have to consider as a gray code, right? So 4 5 6 7, it means 4 is 0. Okay, these two are zeros, and you have to construct you have to form a you have to form octet and order wise. Okay, here I can obtain with don't cares I can obtain octet, so my preferences is octet first. Okay, then after I look for any octet. If there is no possibility of octet, I go for quad. Okay, here but you can carefully observe it. Here we can obtain a octet also. Later that I remaining one is left, so that I can form a quad. Then after I look for remaining one, then I can form a quad here. Okay, after after forming all these with all minterms, then you can get a logical expression by looking at this. You can see this. I will do explain of one of them. Here you can see that a one octet is there, means all these are eliminated. If a octet is present, all of these terms are covered, right? So none of them taken into consideration here. Okay, so only we have to consider these two because it covers up to these two rows, right? Here one one and same, so we have to consider uh, a a. Why? Because a means SOP. In SOP we consider one as a, right? Okay, why? Because a means here up to these rows, up to the in left side of this we consider AB and this CD as here. Okay, 1 and 0 are eliminated, and wherever 1 and 0 comes after forming, after by looking here, then we have to eliminate this, and same terms we should be considered. So here A will be taken into consideration, so I wrote here A. Okay, next is C. How this C obtained means you have to consider next octet. Here this is the next octet, right? You have to eliminate, all these terms because it covers all these four terms, right? So you don't did not take into consideration of these four terms. Next you have to take into consideration about these two terms. Here you look, 1 and 0 are eliminated because these are two are different terms, and 1 is the similar term, right? So you have to take into consideration 1. So took I took A as here. Sorry, C. Here CD is CD, right? Here, so CD. I took CD. Okay, I took C. Next, here a quad is present. So you have to look after here. Next, you have to look after these two terms and these two terms. Okay, 1 and 0 are present for C. So C is eliminated. Next D is present. Next here A B, right? I wrote here A bar B bar. So it should be written like C bar into D bar. Okay, and here 0 1 are the different terms and B is the required term. So B and here D. Okay, so BD. Next leftover quad is here. So you have to take into consideration of these and these and these and these by looking after and consider taking into consideration. Then you got B bar into D bar. Like that you have to simplify all of the remaining B C D by taking column wise from the truth table, and you have to form like this. You get simplified boolean expressions like this. Simplified expression, these are the simplified expressions we got. And for D and for E F G we got this. After solving all these A B C D E F G, next you have to draw the logic diagram, right, by using gates. So we have to, here also we have to get a very concised diagram. So that I took, I took from where you got C bar D bar, and here also for F C bar D bar is required. So I don't want to waste one more AND gate here to here, and I don't want to give like that because it makes more complex. So if there is a chance for taking from here, you have to take a wire and put like this. Okay, so this is the considered logic diagram. And you know that A into here I took not gate, so that I can, A bar is taken from here. Okay, okay, thank you.